Hi there and welcome to another video for the AQA Linear Maths GCSE paper. This is a 1.5 hour non-calculator paper. Let's start straight away. As always, try the question yourself and then mark your work against mine. At times I will do some revision notes on topics I think you need revision on. Right, so for question 1. Reflect the triangle in the line y is equal to 2. So for our 2 marks, the first thing we need to draw is the mirror line, y is 2. Well, that should be easy for you, but if you're not sure what the line y is 2 is, just draw a few coordinates where you know the y number's 2, like 0, 2, 1, 2, 2, 2, 6, 2, something like that. And you'll quickly see that 0, 2 is there, 1, 2 is here, 2, 2's here, 6, 2's over here. So you can quickly see the line y is 2 must be this line here. And labelling y is equal to 2. And we are to reflect the triangle, so this corner stays where it is, this corner stays where it is, and this corner here, it's 2 units away from the line, so you go 2 further units down to here, and you would have yourself the other point. Then you draw in your triangle, and you're done for 2 simple marks. Be careful, some students do this, it's an easy mistake. They think that is the line y is equal to 2 and reflect over here. That is the line x is equal to 2. Okay, the x coordinates along here are 2. So just be very careful not to mess up the first question and get the line wrong. Okay, on this line, all the y coordinates are always 2, hence it's the line y is equal to 2. Easy 2 marks. Next question. A bit of algebra. Expand the following. 3 times x subtract 3 times 6. So that would be 3x subtract 18. Simple. Next one, factorise 5y subtract 10. What divides into 5y and 10? Well, 5 does, and then brackets. 5y divided by the 5 is just y, and negative 10 divided by 5 is negative 2. Simple as that. Now we're to expand and simplify the following. So it's 3 marks for this. So let's do some step-by-step working. Be careful here. Students are going to make a mistake with that negative 5 times these 2 things. Students are going to make a lot of mistakes there. Let's just do it very, very carefully. 3 times 4w is 12w. 3 times 1 is plus 3. Okay, I'm going to change pen to make this clear. Negative 5 multiplied by 3w is negative 15w, and negative 5 multiplied by negative 2 is actually positive 10. Okay, so now we can collect like terms. We've got 12w's subtract 15w's, which must be negative 3w's, and then we've got 3 plus 10, which is actually 13, so plus 13. Be very careful not to make a mistake here. This is what a lot of students would write. They would get the 12w plus 3 correct, and then they would just say subtract 15w, subtract 10. They would not realise it's a negative 5 multiplied by negative 10. Don't make that mistake. Okay, good. Again, 5 easy marks there. Let's go on to the next question. Show that the interior of a regular hexagon is 120 degrees. Now something quite important here, regular hexagon. Regular means all the sides are the same length and all the angles inside are the same. Hexagon means 6-sided. So we want to show that the interior angle, i.e. this angle here, is equal to 120. Okay, now there are various ways of doing this. Okay, the first way, I'm just going to maybe do a little bit of side revision. I'm going to take a different shape. I'm going to take a pentagon. Now a regular pentagon as well. This angle in here is called an interior angle, and if you extend the line of any of the sides of a polygon, the outside angle here is called the exterior. So this one's called the interior, and the outside is called the exterior. Now, if you were to go along the shape as follows, it is a true statement to say that all the exterior angles add up to 360. All these angles add up to 360. That is always true, doesn't matter how many sides on the polygon, the exterior angles of a polygon always add to 360. So the exterior angles of a polygon means a shape with many straight sides, add to 360. That's a bit of revision for you. That is a fact you are supposed to know. Okay? And you can think of that because if you push this, if you were to make this pentagon smaller and smaller and smaller, actually let's just do that with all this. If I was to group this, now imagine I make that pentagon smaller. Imagine I make this pentagon here smaller and smaller and smaller. Let's do that, watch. Can you see that all the angles are actually pushing together and go to a point? Hence they are 360. Okay, so that rule there you're supposed to know. So we could use this rule here. We could state that exterior angles add to 360. Now because it's a regular shape, each one of these must be the same. So we might call that x, and there would be 6 of these exterior angles. One there, one there, one there, one there, one there, and one there. So therefore 6x must add up to 360. So x must be equal to 60 degrees. So if this angle here is 60 degrees, well clearly if you label that as an exterior angle, therefore the interior must be 180 subtract 60, which is 120 degrees, because clearly the interior and exterior lie in a straight line, so they add up to 180. And that is one way of answering this question here. Okay, now I'm just going to actually show you another way. So for, this is probably the easiest way to do this question. Let me just show you another way. Again, let me take a pentagon. And I've shown you this before, but if you want to work out what the interior, all the interior angles add up to, you take one side, draw lines to each corner, and you would count how many triangles you form, and in this case 3. So for a pentagon, the interior angles add up to 3 times 180, which is equal to 540. Okay, and if this shape was regular, you could divide 540 by 5, each of the angles, to get what each one is. So we're going to do that over here with the hexagon. Let's pick a corner and let's draw lines to each corner here. Now, there's 180 here, 180 here, 180 here, and 180 here. So therefore the sum of the interiors, this is a different way of doing it, the sum of the interiors add to 4 lots of 180, which is equal to 720 degrees. Now, because they're regular, you could divide the 720 by 6. So 720 divided by 6 is actually 120 degrees. Therefore, each interior equals 120 degrees as required. So either of those two ways would get you this answer. Okay, next question. We are asked to complete the following diagram using the numbers 1, 2, 3, 4, 5 and 7. And what we're asked to do is that in each of the 3 boxes, each straight line must have a total of 14. So what we're to do is just to try and trial and error get ourselves these here. Now, you've got 1 to practice on, so if we're trying to get 14, let's go for this line here where 9 is the biggest number. You couldn't have 7, could you? Because it would be over 14. You could have 5. Well, you couldn't have 5 because then you would have to put nothing in this box, so you couldn't have 5. You could have 4. If you had 4 there, you would have to have 1 there. Okay, so let's give that a go. If that was 4, then presume I've used 4. Then I would have to have 1 there. Now I've got 9 here. In order to get 14, I'd have to have 5 there. But now I've got myself 14 here already, so in which case I can't do that because I couldn't have anything here. So that attempt was wrong. But let's keep going along this way because I put 4 here first of all as a possibility. So let's now say that 4 can't be a possibility, and instead let's put 3 here. 3 and 9 is 12, so you need 2 here to get yourself up to 14. You've used a 2. 2 and 8 are 10, and you need you need a 4 to get up to 14. Now you've got 3 and 4 is 7, so you'd have to use this 7 to get yourself up to 14. Along here, where could you go now? Well, here you've got 3 and 6, which is 9, and you need the 5 to get up to 14. And lastly, 8 and 5 is 13, and you need a 1 to get there. And here as well, 7 and 6 is 13. You need a 1 to get there. So how I did this, I just did this by trial and error. I looked at the 9, I thought it's the biggest number, it's the easiest one to start with. I tried to put 7 there, couldn't. Then 5, couldn't. Then 4, it looked like it could work, and I worked around with it and it didn't. So then 3 went there, and when I did 3, everything seemed to come out nicely. So it's just a trial and error thing there for your 3 marks. Okay, next question. A company sells ice cream. The average midday temperature and the sales for each month are shown in 2011. Okay, and we're asked to complete the scatter diagram by plotting the values for July to December. The values for January to June have already been done for you. Now let's just think of this. The sales, we would expect sales to go up when it gets hotter, okay, because people would be more likely to have ice cream. Now we've been told that January, February, March, April, May and June have been done, and we are asked to do July, August, September, October, November, December. So on our scatter diagram, we're going to plot 22 degrees against 39. So we're going to plot 22 degrees, which is here, against 39, which would be here. Do a cross like they've done, and then we've done that. We're going to plot 29 against 47. So 29 degrees against 47, which would be here. We're going to plot 20 against 36. So 20 degrees against 36, which would be here. We're going to then plot 14 against 28. So 14 against 28, which would be here. We're going to plot 10 against 22. So 10 degrees against 22. And then lastly, we're going to plot 4 degrees against 23 tons of sales. So 4 degrees against 23 tons of sales as such. And they are, that is our completed scatter graph there. And it was actually for 2 simple marks there. Okay. Now, it says in July, for the next question, the average midday temperature was predicted to be 25 degrees. Use the graph to estimate the sales of the ice cream in July 2012. Show clearly how you got your answer. So the first mark you get for drawing a line of best fit. Okay, now remember a line of best fit. A line of best fit has to try and go through as many as possible and have equal numbers on each side, if possible. It cannot start before the first one starts and can't end after the last one starts. So something maybe like that is not great actually, because when I would go more a bit like that, that seems reasonable to me. We've got 1, 2, 3, 4, 5, 6 on the line, 1, 2 above and 3 below. That's fairly decent, I think, something that looks like that. So we are asked in July 2012, the temperature is predicted to be 25 degrees. Now, to get any marks for a sort of a scatter graph question, you have to draw lines onto, you have to draw interpolation lines on. So 25 degrees, let's draw a line up, and then let's read across, and we're getting approximately 42 when I do that. So you get 1 mark for your line of best fit, and then 1 mark for 42 tons. And make sure you draw lines on the graph. Draw interpolation lines on. or you will not get your mark. Okay? In fact, in the mark scheme, you are allowed anywhere between 40 and 44 tons, but 42 seemed exactly right from what we've drawn. Part C. In December 2012, the average midday temperature is predicted to be 5 degrees higher than in December 2011. Now, going back to December 2011, here it was 4 degrees. Okay? So therefore, it's predicted to be, so it was 4 degrees in December 2011. Now it's going to be 9 degrees in December 2012. Now let's look back at our graph to see if anything on the graph can indicate whether we should increase sales. Now looking back at our graph, although I've drawn a line of best fit here, let me just actually just do it as follows here. Now the reason I've done that is, although as temperature increases, the sales increase. If you notice here, for between, let's say, 3 degrees and it looks like 12 degrees here, sales have not increased at all when the temperature has gone up from about 3 degrees to 12 degrees. Okay, this is pretty much a straight line here. So to say that was a part of the scatter graph is, is not probably very reasonable. When I used this line before, I did use it in a point where in a place where there was a positive correlation. However, here you may say there is no correlation. So looking at that graph there, it looks as if for temperatures between 3 degrees and 12 degrees, there is not much change in sales. So I could write no, and I could state for temperatures between approximately 3 degrees Celsius and 12 degrees Celsius, there seems no noticeable increase in sales. And I think that would be a fair comment to get you the 1 mark there. Okay, next question. This circle is drawn accurately. Work out the area of the circle, give your answer in terms of pi, state the units of your answer for 4 marks. So this is such an easy question, Make sure you get the 4 marks. Now on your sheet of paper it may look different because this has been enlarged or shrunk on the screen, but what you have to do in principle, you get your ruler out. Okay, and let's just change the rulers to say something like that. You get your ruler out and you measure, I'm sure, I can't remember exactly what it is, let's just say it's 3 centimeters. It depends what it is on your page. I can't tell exactly what it is on your page. So draw a radius in, and the radius here would be equal to 4. Right? So, therefore, the area of a circle, state the formula, the area is equal to pi r squared, which would be pi multiplied by 4 squared. Leaving your answer in terms of pi, just do the 4 squared, which is 16, and pi times 16 is just 16 pi. What are your units? Well, you've measured in centimetres, so centimetres squared. Now, just to tell you, if you've got the mark scheme for this, there may be a different answer in the mark scheme because on a page, the measurement might be slightly different than what I've taken there. When I'm looking in the mark scheme, it seems that, they took the radius to be 3. But I took it to be 4. It doesn't matter, it's the same principle. If they took it to be 3, the answer would be 9 pi centimetres squared. Okay, right, next question. Nice easy 4 marks there. Question 7. Solve the following algebraic equation. Very, very, very easy question for 3 marks here. Let's always make sure we get these right. There are x's and numbers on both sides. Let's first of all deal with this -5. Let's add 5 to both sides. And we would get 6x would be 2x plus 18. Right? Now let's get all the x's together. Let's subtract 2x from both sides to remove that 2x. We'd have 4x is equal to 18. Then we divide both sides by 4 and we would get x is equal to 18 divided by 4, which is 9 divided by 2, which is actually 4.5. And before we would move on in our paper, we would check whether this is right. 6 times 4.5. Well, 6 times 4 is 24. 6 times a half is 3. This would be 27. 27 take away 5 is 22. Right? And on the other side, 4.5 times 2 is 9. 9 plus 13 is indeed 22. I know I've got it right. I write down my answer. I circle it on the page just to tell myself I know not to check that later. I got that right. Question 8. Now, we did this in November 2012. I'm not going to go over the rules of angles in parallel lines. You should look there for a bit of revision. But we are told that AB is parallel to CD. So actually, these lines here, AB is parallel to this whole line here. So we're going to have one of these rules going on. We know that Z angles are called alternate. They're equal. We know another rule that goes on with parallel lines. We know F angles, that one and that one, are called corresponding and they're equal. We also know another one. We know that interior angles, that one and that one, interior, add to 180. And the last one that sometimes goes on with these type of questions is opposite angles. We know that, let's say, that angle there and that angle there, opposite, are also equal. Okay, so one of these rules is going on here, one or many of them. We're asked to work out x. Okay. Also note, these lines here are telling us this is an isosceles triangle. Right, let's have a go. If this is 62 here, then this angle here is surely equal to 62 as well, because it is opposite. Okay? And if that angle is equal to 62, then this angle must be 62 because they all are alternate. And because that angle is 62, this angle must be 62 because you have an isosceles triangle. And therefore you can work out x. X must be equal to 180, subtract 62, subtract 62. And if you do that on your calculator, you would get yourself 56 degrees. Okay, so let's just state how we'd actually get the marks for that. I might actually in an exam call that y, and I would say that y is equal to 62 degrees, and I would say it's opposite. Okay, I might even call that z, and then I would say z is equal to 62 degrees as its alternate. And then I would say, I might call that w, and I would say w is equal to 62 degrees, and I would say isosceles. And then I would say, therefore, x is 180, subtract 62, subtract 62, which is 56 degrees. That's just how to ensure you get full marks for explaining your working. So I tend to label them with other letters, not use P, Q or anything like that. I label them myself from the picture, and then I state below how I have worked them out. Okay, question 9. A basketball team has 5 players and 1 reserve. 1, 2, 3, 4, 5 players, 1 reserve. The mean weight of the 5 players is 58 kilograms. The reserve weighs 64 kilograms. Work out the mean weight of all 6 members. So, the mean weight, let's deal with this here. That's telling us if we add these people's weights and divide by 5, we get 58. So, let's do the mean. Mean of 5. Mean of 5. That's equal, we are told, to 58 kilograms. But it is also equal to the total weight of 5, of the 5, divided by 5, isn't it? It's equal to all their weights added up. So therefore the total weight of the 5 must be 58 multiplied by 5. Now you don't have a calculator here, but 50 times 5 is 250, 8 times 5 is 40, so it would be 290 kilograms, right? So the total weight is 290, and that's of 5, total weight 5. Therefore, total weight of 6 must be 290 plus the 64, which is equal to 354 kilograms. And I'm running out of space here. Therefore, the mean is 354 divided by 6. and you're expected to be able to work that out. Of course, this is easy because 360 divided by 6 would be 60, so 354 divided by 6 must be 59, and state your units, kilograms, and you're done. Question 10. The L shape shown below has an area of 12 centimeters squared. All corners are right angles, all lengths are in centimeters. Work out the value of x. So, how could we work out the area of this shape? We know the area is 12 centimeters squared. Can we work out an expression algebraically? Well, if we cut the shape off like that, then I'll call that shape A and shape B, and I would say that the area of A must be x multiplied by 1, which is simply x centimeters squared, right? And the area of B, well, that must be this length times this length. And this length is x plus 2, and this length is 3. So it would be 3 multiplied by x plus 2, which if we expand out is 3x plus 6 centimeters squared. Right? So we know if we add A and B, they must add to 12. Therefore, x plus 3x plus 6 must equal 12. There's our equation. Combining x's, we must have 4x plus 6 is equal to 12. Now you should work down the page. I'm working across because I've run out of space. You subtract 6 off both sides, so you would get 4x is therefore equal to 12. 12 take away 6, which is 6. And x must be 6 divided by 4, which is 3 over 2, which is equal to 1.5 centimeters. And there is your answer. Again, unbelievably easy question for 4 marks. Make sure you're getting ones like this right and you're showing you're working as I've done. Question 11. The relative frequencies of the number of absences in the school are shown on 5 days are shown. There are 1,600 students in school. How many more absences were there on Friday than Monday? Now, a bit of revision here. I'm going to just actually move this down. The relative frequency formula. Relative frequency. Okay, this is equal to how many times something happened. How many times something occurred over how many trials you did. Now, therefore, let's just have a closer look at this diagram here. Sorry. Okay, therefore in this case, the relative frequency in this case is how many times someone was absent divided by how many kids there are in the school. How many trials, how many possible kids could have been absent. So how many more absences were there on Friday than Monday? Let's read off the graph. Relative frequency for Friday, well, let's just read it off there, is 0.05. Okay, and the relative frequency for Monday, reading off the graph, was 0.03. Now, rearranging this formula, if we wanted to work out how many times, in this case, our relative frequency is how many absences, so it's the number of absences, that's how many times the thing occurred, divided by the number of students here, because they are the number of people you're measuring it out of. So if you wanted to measure the number of absences, it's the relative frequency multiplied by the number of students. So if we want to work out the absences, it's therefore, just rearranging this formula, if we want to get number of absences, it must be relative frequency times the number of total students. So it'd be 0.05 multiplied by 1,600. And in this case, it would be 0.03 multiplied by 1,600. Okay, and we're expected to be able to work these out ourselves. Well, let's just think of this multiplied by 5 first of all. 16 multiplied by 5, well, that would be equal to 80, but it's 500ths, so we would divide by 100. So the answer here should be 80. And this one here, 3 multiplied by 16, well 3 multiplied by 10 is 30, 3 multiplied by 6 is 18, so it'd be 48, and divide it by 100 as well, so it'd be 48. So if you want to work out how many more, it would be 80 take away 48, and the answer would simply be equal to 32. And we'd be done. Okay, the next question. Solve the following simultaneous equations. You are not allowed to just guess as x and y's, i.e. use trial improvement. You must use algebra for 4 marks. This is very easy. Let's label them equation 1 and equation 2. I find the easiest way to solve these is make the x numbers or the y numbers the same, whichever you think is easiest. So why don't we make the x numbers the same? Let's multiply equation 1 by 3, multiply equation 2 by 2. That way they'll both have 6x. And let's write down what we get. We would get 6x plus 12y is equal to 3, and we might call that equation 3. And on this one we would get 6x subtract 10y is equal to 14, and we'd call that equation 4. Okay, now we could, let's say, take equations away from each other. Let's take, it doesn't matter what order you do this, let's take equation 3 away from equation 4, the way we have them here. But be very careful with minuses here, be extremely careful. 6x take away 6x is no x. 12x take away 12y take away negative 10y would be 12y plus 10y, which would be 22y. And 3 take away 14 would be negative 11. Dividing by 22, y would therefore be negative 11 over 22. Divide top and bottom by 11, you just get negative a half, or negative 0.5. So y is equal to negative 0.5. If we stick that into one of these equations, let's stick it up in here. So you let's say sub in equation 1, we would get 2x, 4 multiplied by negative a half would be negative 2, so we get 2x, and instead of this we get subtract 2 is equal to 1. Solving it, add 2 to both sides, so 2x must be 3, and then divide both sides by 2, 3 over 2 is 1.5. So the answer we're getting here is x is 1.5, y is equal to negative a half. Next question, work out the following, give your answer in standard form. Okay, when we're doing standard form like this, what we can do is 3 times 10 to the power of 5 multiplied by 6 times 10 to the power of 9. We can take the 3 and we can multiply it by the 6 first of all and get 18. Then we can do multiply by 10 to the 5 multiplied by 10 to the 9. When you're multiplying indices with the same base, you add the power, so that's multiplied by 10 to the 5 plus 9, which is 14. Now the thing about standard form is always in this form here, some number times 10 to the power of some other number. Instead of calling it b, I might call it n here. Okay, it's always like that, and that number a must be, okay, it must be less than 10, and it must be bigger than 1. It must be between 1 and 10. Now currently this is 18, it's no good. So we change it to 1.8, we divide this by 10, and in order to make up for this we'd have to multiply this by 10, so it'd be 1.8 times 10 to the 15. And write our answer here, 1.8 times 10 to the power of 15. Okay, next, 13 part B. Work out the following. We can do the exact same. 3, and we're dividing here, divided by 6. So 3 divided by 6 is a half, so it'd be 0.5. And then 10 to the power of 5 divided by 10 to the power of 9. When you're dividing powers with the same base, you subtract the powers. So 10 to the 5 subtract 9 will be multiplied by 10 to the power of negative 4. Again, this is not between 1 and 10, so we'd have to change it to a 5. Multiply that by 10. To undo that multiplying by 10, because we don't want to change the value of this, we'd have to divide this by another 10, and it would hence be that. So it'd be 5 times 10 to the minus 5. Okay, next question. We are told if we have the following shape, then the diagonal distance here is equal to 1 meter. 4 of these crosses are put together, and it asks us the area of the shape form. Show clearly how you get your answer. Imagine I drew a line from here to here, here to here, here to here, and here to here. Would you agree that each of those distances are 1 metre? Hopefully you would. So the area of this square here must be 1 times 1, which is 1. So area of S is 1 times 1, which is 1 centimetre squared. Now what is the area of these added up? Well, could you imagine that if I added up these outside triangles, they must also add up to that square there, because they are the mirror images of 4 triangles that would have made up that square. So the area, and I could call this, if I colour those red, let's say, I could have stated that the area of this outside bit I'm trying to show is also 1 centimetre squared. So the area of the whole lot must be 2 centimetres squared. Okay, so that would be one way of showing that there. The other way of showing this maybe, let's just take this picture and just extend it a little bit here. I'm just taking this corner here. Okay, we are told that the diagonal length is 1. Okay, so I'm told that this length here is 1 metre. And because this is has the same distance here and here, if that was x and that was x, we would have a right angled triangle, and we would have x squared plus x squared is 1, i.e. 2x squared is equal to 1, so x squared is equal to a half, right? So now, what would the area of this triangle here be? What would the area of this triangle be? Well, it would be the base, which is x, times the height over 2. So it would be equal to a half x squared. So it would be base times height over 2. So it would be equal to a half x squared. Now you know x squared is a half from above, so a half x squared must be a quarter. So therefore, that's a quarter, that's a quarter, that's a quarter, that's a quarter, so they all add up to 1. And similarly, that must be a quarter, that must be a quarter, that's a quarter, that's a quarter, they add up to 1, and hence you have yourself 2 again. So that's a different way of doing it. Next question, question 15. The graph shows the cost of gas from Gasco. C is the cost, so C is in this case along the y-axis, and n is the number of units used, so n is along the x-axis. Use the graph to obtain a formula for C in terms of n. Basically, they want you to name the straight line graph that this is. Now, you should know a straight line graph is y is equal to mx plus c. M is the gradient, and c is the y-intercept. Now, in this case, we haven't got a variable y and a variable x. We've got a variable c and a variable n. So in our case, we're dealing with c is equal to, I'm going to keep m as it is, m in that colour multiplied by n plus little c, where c is the intercept. Now we need to find this number and this number. Now c is clearly 10, so c is 10, that's easy for us to spot. M, well, as you go across 1, how much do you go up? Well, as you go across 100, you go up 5. So the gradient m, which is the difference in y's over the difference in x's, so as you go across 100, the difference in x's would be 100. If you go across 100 here, you go up 5, so it would be 5 over 100, which is actually equal to 0.05. So that is our gradient in this case. So our equation is not y, sorry, it's capital C is equal to 0.05 m plus 10. Okay? Right, next question. We're told y is inversely proportional to the square of x when x is 3, y is 8. Work out an equation connecting y and x. Y is inversely, must be equal to k over, the inverse tells us that it's over the square of x, x squared. That would get us 1 mark. Now we're going to substitute in. We know when x is 3, y is 8, so we're going to sub that in. 8 must equal k over 3 squared, so 8 is equal to k over 9, and so rearranging this, k must be 8 times 9, which is equal to 72. Okay, so let's state our equation for the final mark. Y is therefore k, which is actually 72, over x squared, and that's our 3 marks. Okay, part B, work out the value of y when x is 12. Give your answer as a fraction in its simplest form. We know that y is equal to 72 over x squared. And we want x to be 12 here, so y must be 72 over 12 squared. Y must be 72 over 144. If we divide top and bottom by 72, 72 goes into 72 once, 72 goes into 144 twice, so y must be a half, and that is it in its simplest form. Next question. We're asked to do a bit of algebraic fractions here. Firstly, we're asked to factorise the following. Okay, now 2 ways to do this, long way or short way. The short way is to think 2x squared. How would I get a 2x squared out of 2 brackets? Well, I'd need a 2x in one and I'd need an x in the other. And how would I multiply to -3? Well, it would have to be 3 and 1. 1 would be plus and 1 would be minus. So you just have to decide which one's which. Now, if that was a -3 here, I'd get a -6x. I'm never going to get myself back to -1x. If it was a +1 in here, let's say, and a -3 here, would that work? Well, 2x times x is 2x squared, 2x times 1 is 2x, and -3 times x is -3x, so you get the negative x, and -3 times 1 is equal to -3, so you've got it. So we do know the answer is 2x minus 3, x plus 1. Okay, the long way, what we used to do is we used to do 2 multiplied by -3 is -6, and we would think of 2 numbers that multiply to -6 and add to -1, and the 2 numbers that multiply to -6 and add to -1 are -3 and 2, and then because that's 2x squared, we would say 2x minus 3, 2x plus 2, and we would make sure we simplify where we possibly can. Can't simplify anything here, could divide this by 2, so we get 2x subtract 3, x plus 1, and we get the same answer. So do it whichever way you feel comfortable with. Hence means using part A, simplify the following. Now, whenever you're trying to simplify algebraic fractions, factorise the top and the bottom first, and you will notice things cancel. The top, oh, we have factorised that in part A, and it factorised to 2x subtract 3, x plus 1. Now the bottom is a difference of 2 squares. You should see that when you've got a square number take away another square number, they factorise to a plus b, a minus b. Here, our square numbers, well, we've got 4x squared, subtract 9. What squares to 4x squared? Well, 2x. And what squares to 9? 3. So it'd be 2x plus 3, 2x minus 3. So on the bottom, we would have as 2x plus 3 or 2x minus 3, 2x plus 3. Now look what happens. That cancels off top and bottom because it's multiplying on top and bottom, and we would get x plus 1 over 2x plus 3. A difficult question, but we've got ourselves 2 marks here and 2 marks here. Okay, next question. Write root 72 in the form a root 2. Now, we're given a hint here because we've got root 2 here. Firstly, write down your square numbers 1, 4, 9, 16, 25, 36, 49, 64, etc. What's the biggest square that goes into 72? Well, 36. You could write 72, root 72, as root 36 times 2, which would be root 36 times root 2, which is simply 6 root 2. And a is therefore 6, so 6 root 2. Work out the following, give your answer in the form a number plus a number lots of root 2. Now, this here is like multiplying out brackets. Root 6 plus root 12 multiplied by root 6 plus root 12. Okay, let's do it step by step. That multiplied by that. Root 6 times root 6 is root 36, which is 6. Root 6 squared must be 6, right? Root 6 times root 12 is root 72. Okay? And then root 12 times root 6 again is root 72. And root 12 times root 12 must be root 144, which is 12. Now we combine the 6 and the 12 and we get 18. And root 72 plus root 72 is 2 lots of root 72. Now from part A, we know that root 72 is 6 root 2. So this is 18 plus 2 lots of 6 root 2, which is simply 18 plus 12 lots of root 2, because we could just multiply the 6 and the 2 and get that. And it's fairly straightforward here for 4 marks. And question 19, the graph of x squared is transformed by the vector 0, 2. That means we go across 0 and up 2. You can see that the graph's been shifted up 2 units here, nothing across and 2 units up. Write down the equation of the transformed graph. Okay, this graph here, y is equal to x squared plus 2. That is the answer. Let me just do a tiny bit of revision here on this one, or for some of you this would be brand new. If you have a function y is equal to f of x, some function of x, okay, for example, the x squared function in this case, right? If you do f of x plus a number, f of x, let's say plus 2 here, which would be the same thing as x squared plus 2, doing that to f of x actually shifts the function up by 2. Okay? Now if I did f of x subtract 2, which would be the equation x squared take away 2, it would shift the function down by 2. Okay? So something of the form f of x plus or minus a number is always a shift up or down by a units in the y direction. Now this is as opposed to what I'm going to show you just to follow here. Now imagine everything there is the same as it was. I'll just move everything up so it's got a bit more space. If I kept my same function, but this time instead of f of x plus 2, what if I worked out f of x plus 2? i.e., instead of putting x into my function, I'm going to put x plus 2, i.e., replace x by x plus 2. Something like that. Okay? Now, this actually turns out to be a translation in the x direction, but by negative 2 units. It does the opposite thing to what you think. When the plus 2 is inside the brackets, it goes the opposite way to what you think, and it goes in the x direction. When the plus 2 is outside the brackets, it goes in the way you think and in the y direction. So if I was to do f of x subtract 2, in this case replace x by x take away 2, i.e. work out x take away 2 squared, that would be a translation in the x direction, but in positive 2 direction. So anything of the following, f of x plus a turns out to be a translation in the x direction by negative a units, and f of x minus a turns out to be a translation in the x direction by positive a units. Now that's just a very, very quick whiz-stop tour of that. But in this case here, knowing that I want to go up in the y direction by 2, I know I need to add 2 outside the brackets. So I've just added 2 there. Let's see if this comes up in part B. Well, it does. On the same diagram, sketch this here. The plus 1 is inside the brackets, so it's in the x direction. That tells me first it's in the x direction. The plus 1, does opposite to what I think. It makes me go shifting that way by 1 unit. So this graph here was at 0, 0. It's now going to be at negative 1, 0. And it's going to be exactly the same as that, apart from that shift there. Sorry, that was, I don't know what's happened there. It'd be exactly like that, apart from a shift in that direction by 1 unit. Okay, and the last question here, we have a histogram. The company has 800 workers. The table and the histogram show the distribution of weekly wages, and we're asked to complete both the table and the histogram. Now remember, with a histogram, you should remember this, a histogram, key fact, the area is equal to the frequency for a histogram. The area of a bar tells you how many people in that bar. Okay, and frequency density is frequency over the class width. And the reason that's true is because the frequency density, which is the height of a bar times the class width, must be the frequency. This is just from this formula here. So, in this case here, what is the area of this? Well, it's 0.9 multiplied by 100, which is going to be equal to 90. So this here would be 90. This here would be 100 times 1.5, which is 150. That's what I've got. This here is 50 multiplied by 2.7 here, which would be 140 as we've got. And we have to draw the rest. Now, between 250 and 300, we have 120. So we're going to go across like this. Between 250 and 300, we need 120. So we've got 50 width here. What height do we need? Well, if we went up 1 unit, that would simply be 50. If we went up 2, that would be 100. And each 0.1 adds us 5. So we'd have to go up to 2.4. Because 2.4 times 50, let's just double check that's right. 2.4 units multiplied by 50, or 2 times 50 is 100. And 0.4 times 50 is 20. That gives me the 120 I'm looking for. And then the 20 is done for the last column between 500 and 600. And between 300 and 500, so this last bar here, we want... Oh, well, we can easily work this out. We know this must add up to 800, so you just add these up. So you would just do in your head 90 plus 150 is 240. Plus another 140 is 380, plus 120 would be 500, plus 20 would be 520. So 800 take away 520 would be 280. So it would need to be 280 in here. And we've got a bar width of 200 here. So if we go up 1, that would give me 200. And each 0.1 is 200 times 0.1 is 20. So this here would be 200, 220, 240, 260, 280. It would be this here. And let's just double check that. That's 1.4 times 200, which is 280. And there we're done. And that is everything on that paper for you to revise from. Thank you for watching.